And for animations, it's easy to show this page. That talks a little bit about, we have different ways for basically to say if you change a property on the layout, then the objects will animate smoothly from their current position to where they need to be to fit in that layout. And so the curve animator here it's showing is whenever I'm swapping the position of the object that is getting dragged, the other objects are moving to fill in to fix their positions. And the curve animator works by defining this curve. I can show this in Unity actually. So if I create a flexible layout, let's just stick some cubes in here. And so if I add the curve layout to these, so sorry, the curve animator, then I can define this curve. And what this does is say, okay, the object is going to start at some position. You don't know exactly where. And it's going to end up at its layout position. What kind of curve should its path take in terms of the rate of change? And so if you say, I want something like this, it's going to start off going very quickly and then slow down towards the end. Similarly here, it's going to start off slowly and then speed up as it gets closer to its target position. And this will kind of give you the sine effect of you start off slow, you go fast, and then you slow down when you reach the end. And if you wanted to, I've gotten this question a couple times, if you want it to go, if you want the whole animation to be faster or slower, you can say, how long should this entire thing take? And you can see at the bottom, there is a timeline and saying it's going to take up a total of 1 second. So you can change this and say I want it to actually take, I'm holding down shift to keep it on the 1 at the top, and you can see that it can go down to say a third of a second or so. And then when I play, and if I swap the positions of the objects, then you can see that they animate smoothly into place. So similar to the curve animator, we've got this lerp animator. And the difference is really that, well, the implementation is different. So the way the lerp animator works is that it is constantly chasing the end position by interpolating from its current position to some fraction from its current position to its final position. And so it might say every time I'm going to move 10% closer to my final position. You can get this effect of it's always kind of starting quickly as it, that 10% is a large chunk of the space, and then it's slowing down when it reaches the end. And the real benefit of using this animator instead of the curve animator is that you get these, you can see here, I'm constantly changing the target position, and the objects are smoothly moving towards that target position because all the lerp animator is doing is saying 10%, 10%, 10%. If I use the curve animator here, then every time I change that target position, it's going to recompute the curve from the start. And so it's always going to start the curve over, and you'll see the objects are moving very slowly, or whatever is at the very beginning of your curve, until the target stops, and it can finish that curve. So you have different use cases for lerp animator if your target's constantly changing, and curve animator if you want a different sort of curve, but your target is not constantly changing. And then finally, you've got this fun rigid body animator, which is useful. And I'm going to have a cool demo to show how to set this up, where the objects are moving towards their target positions using physics forces that come from the rigid body animator. So it's constantly using, I think it's called add force function on the rigid body to say, always push the object towards its target layout position. And I'll talk a little bit about this, but you can also animate the layouts themselves using standard Unity animators. I'll show an example of how to do that, where Maybe you want to animate things along a curve. You want the circle to rotate. You can just animate the properties on the layouts themselves to create these interesting effects.